Hello. So, good morning. This is the question which was assigned to me in the exam. So, basically, the question says that this is a straight bar having a length of 180 and 200 mm respectively, and the diameter it's having is like 15 and 20, 15 and 10 mm respectively, and 5 kilonewton is applied towards this bar, and 2 kilonewton is applied towards this bar. So we have to solve this using FEM, where we will present out the nodal displacement at B and C. So first we will design this model in CAD software, uh, in FreeCAD software actually. So I will design here, then I will export this and import this in ANSYS, and will for and proceed further. Okay. So in new sketch I will select any plane, let's say X-Z, and I will draw a circle from center having a diameter of 15 mm, and the sketch is fully constrained. Now I will pad this. The length is 180 mm. Okay, and now at any face of this bar you can select and draw a new sketch and follow the same procedure to draw the second bar. So here I will do the same thing again, 10 mm. Okay, so here we go. All thing is fully constrained. Now I will close this and will add this again with a length of 200 mm. Okay, so here we go, we got our CAD model easily in this. I will now export this from FreeCAD with the name of, let's say, step part. Okay, the file is exported successfully. Now I will select static structural, where I will import this file. Before that I will go to engineering data to set out the values, where here we go. So Young's modulus is this, but in question it was given 2 into 10 to the power 5. So I will cut it down the value to this 1, 2, 3, 4, 5, 2 lakh. Okay, and the Poisson's ratio is 0.3. So it's already been set in this, so we do not need to change this value. Now in geometry I will import the design that I have created in FreeCAD, browse and step bar. Okay, this file I exported that in IGS file so that it will be handy to operate in ANSYS. Okay, the geometry is imported successfully. That's why the tick mark is showing here. Now in model I will follow the respective procedure to solve this problem. It takes some time to load, so we can wait for that. So here is our CAD model which I have designed earlier in FreeCAD. So now I will go to mesh and insert sizing, and in sizing I will select all the faces of this model, 1, 2, 3, 4 and 5. I've selected all the faces and I'm clicking to apply. All 5 faces are selected here. Now I will generate mesh. Wait, before generating the mesh I will select the element size. I am taking a random number, let's say 10. It's like one of my fair number, anyways, that doesn't matter. Now I will generate mesh. Yeah, it's generated. So it's not looking that much good, so I will do refinement, and in refinement I will select all the faces of this model again, 3, 4, and here is 5. Applied. Okay, all the 5 faces are selected. Now I will generate the mesh again. Yeah, now you can see it's looking very smooth here. So now I will proceed further. I'm now entering to static structure where I'm inserting now fixed force, and I will be inserting the fixed force and fixed support and forces here. I will insert two forces as it is a step bar. Two forces are acting on each. Okay. So in question, here we go. In this question, here the fixed support is there, and on this 5 kilonewton is applied, and here 2 kilonewton. So we'll go according to that. Here I am selecting the fixed support and selecting this face applied. This face is fixed now. Here you can see the tick mark, so you can confirm that it is selected. So I'm putting a force of 2 kilonewton on this according to the question. The face is selected, and in definer I will go to components. Okay, and in which component I have to see, it's like showing negative z-axis. Okay, because negative, I am saying negative because the force is acting inwards, so negative z-axis. So that's why I'm applying minus 2 kilonewton force to it. You can see now, yeah, it's acting actually inwards. Yes, that's correct. So according to that, we will be adding another force here. Okay, on this face applied, and in components, we will apply minus 5. So let's see now, is it correct or not? Yeah, it's correct. So fixed support, force and force 2 all are showing tick marks, so which indicates we can move to the further part. So here in solution I am inserting deformation in order to get the nodal displacement. Sorry, I am inserting total directional deformation in order to get nodal displacement at point B and point C. Okay, so before that I am adding total deformation, and after that I am going for directional deformation. Okay, so I have to assign where the directional deformation will happen. So I am selecting this place, apply, okay, and this one I will do the same, apply, okay. Now I will solve this. It will take some time, so we have to wait for that. Yes, so here is the result. In this part you can see it's maximum, and this part is minimum, and this part you can guess about the value by matching the colors. So if you can match the colors, then you can get the idea that what is happening here actually, what is happening actually. Yes, no, it's okay. Okay, now I will animate this. Okay, here is the animation. So it's not bending, so we can know that it is correct now if it is not bending. And directional deformation, here we go. I'll animate this one is showing this, and in directional deformation 2, this is the animation of that. So in total deformation, it's not bending. So we can say that we have done the correct thing here. Now, in question, what is asked? It is asked that determine the nodal displacement at point B and C using FEM, right? So I will extract the data from here. Export, export text file. Okay, it is deformation C. Okay, C, and it is. I'm exporting also this one. Deformation B. So in Excel sheet we can go. First we are going for deformation B. So at point B, here is the nodal displacement, and there are many nodes there. That's why all this is the directional deformation or nodal displacement of all the nodes. Okay, these are the numbers. This is quite huge also. So this is the deformation directional deformation of point B, and this one is the deformation of point C, as there are many nodes, so it is showing like this. Okay, so I'm animating this part for the last time. You can see the answer. Okay, so that's it. So this was the answer of this question. So thank you.